Okay, so I'm presenting friction measurements on the wheel-rail interface. There's lots of different types of measurements you can make to measure friction, loads of devices, and they vary between lab and field. Presented there is the spectrum from several different studies of friction measurements in various conditions, from dry to wet to lubricant or a friction modifier. As you can see, the measurements are in a spectrum, but depending on the device used, there's a shift. Also with the devices, you get different outputs of the measurement, so you can measure a creep curve within a single test. That reduces the amount of tests you have to do, gives confidence that the test conditions are similar within a one test. Or you can measure individual adhesion values over several tests using fixed creepage. So you measure the creepage at a fixed value, and you can get additional information from tests. So you can have a look at your wear. You can simulate rolling contact fatigue, various bits depending on what size of test equipment you are using. However, once you go to the higher levels, so if you go into the field, you're sacrificing control for a realistic wheel-rail adhesion. Friction's a system property, so you kind of really need these. Yeah, it needs to be realistic, but you need to be able to control factors to do the testing. So I'll be presenting a few lab studies, a few field studies, and the measurement and comparing and contrasting the different values that we've measured. For the lab tests, we're looking at a full-scale test facility. There's actually a presentation coming up on that, so I'll hold back on that. We're looking at comparing that to a Saurus rig, which is a twin-disc test rig which has been used extensively, and then finally versus a pendulum rig, which I'll explain in a second. In the field tests, we use to compare between field and lab. Pendulum is portable, so we'll compare pendulum values from the two, and we'll also have a look at measurements between the pendulum and the push cribometers in the field. We'll be varying, the studies varied material type and then interface conditions. Within interface conditions, we looked at dry, wet, and a friction modifier, a water-based soluble friction modifier. So full-scale test facility is at Sheffield University. It's a full-wheel actuator to give you a normal load, a rail on a slide bed with another actuator to give a movement, and a slip actuator to control the slip. Within a test in the full-scale rig, you can run it. You run at a relatively low speed, but it's a realistic contact, and it's the realistic loading. The Saurus rig, you can run at a slightly higher speed, but it's two twin discs controlled. The Saurus rig, you can also either run you can run at a fixed creepage, or you can build a creep curve within one test, so that adapts. Pendulum rig it was designed as a floor tester to test the floor. We've done several studies on testing friction on the railhead. It's a sliding contact, and it's measuring an energy loss over a known sliding distance. It's a hard rubber pad against a steel surface, so it's not as realistic as the other two. For the full-scale rig, we're looking at different loads, and we're looking at dry, wet, and top of rail friction modifier. For the Saurus rig, the twin disc rig, we're looking at varying the rail steel hardness at a fixed load. And for the pendulum rig, there's several different studies, but looking at dry, wet, friction modifier. I'm not going to present the variable amounts within this presentation, it's in the paper. And then we're looking at rail steel at different locations. So for the field tests, we were looking at pendulum, top of rail and gauge. We're only presenting the top of rail. And then 2 different tribometers. So the tribometers can be used in the field for measuring friction. It's a braked wheel. They're basically the same, the salient systems and the tribometro. However, the salient system outputs one value, a peak value, and the tribometro will output the peak value but also record the creepage over the duration of the test. We were tested in the UK and Colombia, quite dramatically different environments, but the temperatures weren't too different. It says 7 test sites, that's a lie, it's 6 test sites. Access to track's a bit difficult, so in the UK especially. So we've got Long Marston, which is a closed-loop test facility, Severn Valley Railway, which is a heritage railway line, and then Windermere and Oxone, which is a rarely used, it's on the UK network, but not as used. And then we've got tests in Colombia on the Metro in Medellin at 3 different locations. This is just a table describing what we tested where. And so the rail steels were tested in Colombia, and the different values between dry, wet, and top of rail were tested in the UK here. So lab results, at the top right, we're looking at dry, wet, and top of rail friction modifier. We're building up creep curves, and the full-scale rig is able to differentiate between different contact conditions and different loading conditions. We're looking at, and then we can compare that full-scale rig with the Suros rig, where we, even though the absolute normal load is slightly different, the creep curves we get out are very, very comparable. So here's some of the pendulum results. I'm not presenting them all. Pendulum results are the adhesion value is much higher. You can't tell from the rail material using the pendulum, but you can with the push tribometer, which I'm not actually presenting here. Anyway, yeah, as you can see, the adhesion values of above 0.8 would not be expected in a wheel-rail contact, but the pendulum is able to indicate and measure a slight difference between dry and wet and friction-modified conditions. Then we can have a look at the pendulum full-scale rig and Suros. For the Suros and full-scale rig values, we've looked at 5% slip, and so it's a fixed value. Sorry, pendulum is a full sliding contact, so hence we're looking at above a higher percentage of creep for the sliding. They give the same trend across all the rigs, but different values. The pendulum is based off slippy floors, so conversion rate may need tweaking for looking at the rail contact, but we're getting the similar results. Field test, looking at the pendulum in dry, we're able to measure it, but you can't tell the difference between the steels. However, with the push tribometer, there was a clear difference within, especially the different types of steels on the Metro in Medellin. Slight different to what we found in the full-scale rig. Having a look at the laboratory versus field, the pendulum gives similar values when you're testing in the lab to when you're testing in the field. Still too large, but it'll give you an indication of the state of a railhead. So from the lab, full-scale test facility, we can measure the change coefficient for different loads. We can measure it for different contact conditions, and they show good agreement with our twin disc tests. Field, the pendulum can differentiate between different contact conditions better than we could with the tribometer, but the conversion's not quite right. The pendulum is able to give a differentiation between, using the pendulum in the field, you'll be able to compare across and give you an idea of what the state of your railhead adhesion is. It's very simple to use. That's it. Thank you.